Good morning students, welcome to this video. Now today in this video we are going to discuss a very important concept, and this concept is all about your equivalent fractions. Actually this is very important in entire mathematics, be it there the mathematics of your primary classes or your secondary classes or senior secondary classes or beyond that also, because this concept of equivalent fractions you will get this word everywhere, almost at all the levels of mathematics you are going to get it, and as well as in your competitive exams also you will get the concept of equivalent fractions. There are many questions which are framed on the concept of equivalent fractions in your various competitive examinations. So dear children, you must have understood that how important this concept is. So today in this video I am going to tell you in very detail that what's the concept of equivalent fractions and basically what these are. So are you ready to explore this particular concept of equivalent fractions? Okay, yes. So let's begin with the video. Let's start at equivalent fractions. So here I am beginning with a question, and the question is that is the shaded part in each pair of figures same? So Abhi, what I am going to do, I am going to show you some figures, and in those figures there would be actually two figures, and hence a pair of figures would be formed, and in that pair of figures you have to tell that the shaded part in that pair of figures, is it same or not? This is the question. So let's begin with it. Let's start with it. So this is your first figure that I am showing you, and here, yes, this one is your first figure, it's a circle, and the second figure is this one. So here are the two figures. You can easily see these two figures, and these two figures combinedly they are making a pair of figures, and what you have to tell that the shaded portion in these two figures, is it same or not? So yes, for this particular pair of figures, what you have to say. Now see here, these two circles are exactly same, and here in the first circle this one is the shaded portion, and here in this second circle, which is exactly identical to the first circle, this one, this shaded portion is again same. See the quantity, the magnitude, the quantum which is being shaded in both these two identical circles, it is exactly same. So therefore what's the answer? That the shaded part in this pair of figures is what? Yes, this is same. So what's the answer for it? The answer is yes. Now dear children, in my previous video I discussed in detail that what's the concept of fractions. So applying that same concept, here you simply write down that what's the fraction which is represented by this figure. It's very simple. The fraction is written in numerator upon denominator form, and in numerator what we write down in numerator? The number of parts which are shaded. So here number of parts shaded are 1, and total number of parts, total number of equal divisions or equal parts, it is written in the denominator. So with this sense, what's the denominator over here? The denominator is 1, 2, 3, 4. Denominator is 4, and what's the numerator? Numerator is 1. So let's write it down. So here your numerator is 1 and denominator is 4. Likewise, dear students, what you have to say about this thing? Here the numerator is what? The numerator is going to be 2, and what's the denominator? The total number of equal parts, 1, 2, 3, 4, 5, 6, 7, 8. Yes, exactly. So here the denominator is 8 and numerator is what? It is your 2. Now let's see another pair of figures. this is your another pair of figures. Yes, we can see it here. This is one figure and this is second figure, and these two figures combinedly they are forming a pair of figures. Now what you have to tell that the shaded part, is it same or not in these two figures? So what we are finding that these two rectangles, these two complete rectangles are exactly identical, are exactly same, and here this entire first row is shaded, and here also this entire first row is shaded. So what's the answer to this question for this pair of figures? The answer is yes, same. The shaded portion in these two figures is again same. Let's find out the answer. Yes, the answer is again yes. Now dear children, let's write down that what's the fraction for it. What's the fraction for this figure? Here total number of parts are 4 and shaded portion is 1. So the fraction would be 1 by 4. And here in this second figure, the total number of parts are 8 and number of shaded portions are 2. So fraction would be 2 upon 8. Now dear children, let's move to the next pair of figures. Here we get this. This is our next pair of figures. So here again we are seeing two circles are here. This is your circle number 1, this is your circle number 2, and we can easily find out that these two circles are exactly identical. These two circles are exactly same. Yes, here we can easily observe it from the figure that these two circles are exactly same. And let's see the shaded portion. Here this much is the shaded portion of this first circle, and here also this much is the shaded portion of this second circle. So what you have to say, from this line segment to this line segment, this much is your shaded, this line segment up to here, and here also from this line segment up to here, this line segment, this much is shaded. So what you have to say, that shaded part in this pair of figures, is it same or not? The answer is simply that it is also same. So let's find it out. Yes, the answer is yes. The shaded portion is again same. Now dear children, let's write down that what's the fraction for it. So here the fraction is what? The shaded number of portions are 3 and the total number of portions are 4. And similarly, what about this fraction? Here the shaded number of portions, how many shaded number of portions? 1, 2, 3, 4, 5, 6. So the numerator would be 6. And what about denominator? 6 plus 2, 8. The total number of parts are written in the denominator. So here the denominator is 8, and what is the numerator? The numerator is 6. So I hope that this would be clear to all of you. Now let's find out that what's further we are having in this video. Okay. So simply the question is that, is the shaded part in both the figures same? Now here some more examples are given. Yeah. Here also, here again we are finding that these two circles are exactly same. These are identical circles, and here half of the circle it is shaded, and here also half of the circle is shaded. So the shaded part, is it same for both the figures? The answer is yes. And dear children, what you have to say about the fraction? Here the total number of parts are 2 and shaded portion is 1. So what would be the fraction? The fraction is total number of parts 2 and shaded is 1. Similarly here, what is the fraction? The fraction would be shaded number of portions 1, 2, 3, 4. So in numerator we have to write down 4. And what will come in denominator? The total number of equal parts. 4, 1, 2, 3, 4. 4 plus 4, 8. Yes. In denominator it would be 8. Okay, now let's see what is the fraction for the shaded part? What's the fraction? The fraction is 1 by 2. 1 by 2, yes. And here what's the fraction? The fraction is 4 by 8, that we already did it. So what we see that 1 by 2 is equals to 4 by 8, means the amount which is represented by 1 by 2, it is exactly same the amount which is represented by 4 by 8. So here what we are seeing, that these two fractions are exactly same, or in other words what you can say, look here, simply when you are going to represent this 4 by 8, now what you have to do, this 4 by 8, it is not expressed in the simplest form. Let's express this 4 by 8 in simplest form. So how we can do it? We can divide these two numbers by what? By 4. These two numbers are the multiples of 4. The highest common factor is 4. So therefore on dividing it by 4 and hence converting this number in the simplest form, what we are going to get? We are going to get 1 upon 2. So what would be the answer? It is 1 upon 2. So here what we saw, that this fraction in its standard form, in its lowest form, is nothing else but this is equal to this fraction only. So here these two fractions are basically same. 1 by 2 and 4 by 8, they are basically same, because 4 by 8 in its standard form or in its lowest form, it is representing 1 by 2 only, and this fraction is also 1 by 2. So these two are basically equal fractions. Such fractions which are basically equal, but they are looking different. Here it's looking 1 by 2 and here it is looking 4 by 8. So they are looking different, but actually they are same. So such fractions are called equivalent fractions. Okay, let's see that what further we are having for you. Now here again it's a question, is the shaded part in both the figures same? Again the same type of question, and the answer again is yes. Why the answer is yes? Because here the number of shaded portions are 1 and the total number of portions 1, 2, 3, 4. So the denominator would be 4. And here what's the fraction for it? The shaded number of portions are 2 and the total number of portions are what? 1, 2, 3, 4, 5, 6, 7, 8. So in totality the denominator is 8. Now look here, what's the special thing about these two fractions? This is your 1 by 4 and this is what? 2 by 8. Here when we are going to divide this, or when we are going to convert it into the lowest form, then what we are going to get? The HCF of these two numbers is 2. So when we divide it by 2, what we get? 2 1s are 2, 2 4s are 8. So basically this fraction is what? This is also your 1 by 4. So here what we are seeing, that 1 by 4 and 2 by 8, that is this entire figure and this figure, they are representing the same fraction. They are representing the same fraction. The only difference is that they are looking different. Simply they are looking different. It is looking 1 by 4, it is looking 2 by 8, but basically 2 by 8 is also 1 by 4. So such fractions which are basically same, but they are looking different, are called equivalent fractions. They are looking different. These two fractions are looking different, but basically they are same. So such fractions are called equivalent fractions. So here the simple question for you is that what's the fraction for the shaded part? This already we did it over here. So here it is 1 by 4 and for this thing it is 2 by 8. We already calculated it. It is 2 by 8, it is 1 by 4, And what's the answer to this question? The answer is yes. So what we see in totality, we see that 1 by 4 is nothing else but it is equal to 2 by 8. So basically these two fractions are not different, simply they are looking different, but actually they are same, because 2 by 8 is nothing else but 2 by 8 is also your 1 by 4. Now students, here the final statement I am giving you, fractions which are equal in their value, basically when both the fractions are converted to their lowest terms, and then if they are equal, it means that they are equal in value to each other, are called equivalent fractions. So what's the definition of equivalent fractions? The fractions which are equal in value. Equal in value means when they are converted to their standard form, both the fractions are same. Such fractions which when converted to their standard form are same are called equivalent fractions. But equivalent fractions, they only look different, but actually when they are expressed in their lowest form, they are exactly the same. So such fractions are your equivalent fractions. For example, 1 by 2 is equivalent to 2 by 4. Why? Because 2 by 4, when it is expressed in its lowest form, it gives you 1 by 2. Simple. Likewise, this 3 by 4, this 3 by 4 is equivalent to 6 by 8. Why? Because this 6 by 8, when it is expressed in its lowest form, it gives you 2 3s are 6 and 2 4s are 8. So basically this is 3 by 4, this is 3 by 4. In the lowest form these are same, but they are looking different. They are simply looking different, but in their lowest form both these are same. So such fractions are called equivalent fractions. Now here it's a very good exercise for you people. Let's find it out that what it is. Simply you have to match the following equivalent fractions. Here some fractions are given to you, and here also some fractions are given to you. You have to simply match it. You have to simply match it. So yes, how you can do it? Okay. So first of all, write down the fractions for all these. This is what? 1 upon 2. This is 1 upon 2. This is 1 upon 3. 1 upon 3. This is completely 1. And this is what? 1 upon 1, 2, 3, 4. This is 1 upon 4. This is your 1 upon 4. And likewise here, this is what? 1, 2. Two portions are shaded, so numerator is 2 and total portions are 8. This is 2 upon 8. This is what? 2 upon 4. This is what? 2 upon 6. And this is what? This is what? Complete. All the three parts are shaded. Total number of parts are 3. Total number of parts shaded are 3. So this is your 3 upon 3. Now simply what you have to do? You have to match it. You have to match it. So let's begin. Yes, this is half of the circle is being shaded here, and here also we are seeing half of the circle is being shaded here. So these two are equivalent fractions. And also here what we are finding? We are finding that this 2 by 4, when it is expressed to its simplest form, it is nothing else but 1 by 2. So here the simplest form 1 by 2, and here the simplest form 1 by 2. These two are basically equal, but here they are looking different. It is 2 by 4 and it is 1 by 2. So such fractions are equivalent fractions. Dear students, what would be the answer for it? 1 by 3. What would be the matching for it? I hope you have did it. Let's see the answer. Yes, 1 by 3 is equivalent to 2 by 6. Here the number of portions which are shaded is this one. Here also it is this one. So here what we see that 1 by 3 is equivalent to 2 by 6. Why? Because 2 by 6 in its lowest form it is 1 by 3 only. Now what about the next one? This is your complete one. And what's the complete one? Yes, here this one we are seeing that this is the complete one. this is the complete one. So of course these two are equivalent fractions. Let's find out the answer. Yes, this is the answer. This is your 1. This is 3 by 3 is what? 3 by 3 is your simply 1 by 1, and this is equals to 1. And finally the last one, this is 1 by 4. This is 1 by 4, and what's the matching for it? Here also this is what? This is 1 by 4 in its standard form. So what's the answer? This is the perfect matching for it. So here in this way we see that what's the concept of equivalent fractions. So dear children, what are equivalent fractions? Equivalent fractions are basically the same fractions. They are basically the same fractions, but they only look different. So such fractions are called equivalent fractions. And how we get equivalent fractions? For example, this is your fraction 1 by 2, and we want equivalent fractions of 1 by 2. So simply what you have to do, you multiply numerator and denominator with the same number. For example, if we multiply it with 2, we will get numerator 2, denominator 4. So this is one of the equivalent fractions. Now you multiply this same 1 by 2 with the same other number. Say the other number we have chosen is 3. Now you multiply 1 with 3, answer would be 3. You multiply 2 with 3, the answer would be 6. So the next equivalent fractions, it would be what? 3 upon 6. And what next? If we multiply numerator and denominator with 4, we are getting 4 here and we are getting 8 here. And likewise we can write down infinite number. We can write down infinite number of equivalent fractions of a given fraction. How? When the numerator and denominator, they are multiplied with the same number, then the results that we are getting, all these are equivalent fractions of the given fraction. So hence, of a given fraction, how many equivalent fractions are there? There are infinite number of equivalent fractions. So students, I hope that you must have understood this particular topic of equivalent fractions. It's very interesting, it's very easy also, and as well as it's very important as far as the mathematics of all the classes is concerned. So go through this video and like this video and subscribe this channel, so that my further videos that I am making in the subject of mathematics, that you are getting on in the notification of a YouTube channel. So dear students, subscribe to this channel and make your friends also to subscribe to this channel, so that you can watch out these interesting and important videos on your subject mathematics. That's all for this video. Have a good day and bye-bye.